Welcome to Crashcast Java, where we dive deep into Java concepts to help you become a better developer. I'm Victor, and today we're joined by Sheila to discuss an important concurrency tool in Java, the ReentrantLock.
Thanks, Victor. I'm excited to explore this topic with our listeners. Before we jump in, let's set the stage. ReentrantLock was introduced in Java 5 as part of the Java util.concurrent package, and it's still very relevant today for managing concurrent access to shared resources.
Absolutely, Sheila. To understand ReentrantLock, let's start with a simple analogy. Imagine a bank vault that can only be accessed by one person at a time. The lock on this vault is like a basic synchronization mechanism in Java.
That's a great analogy, Victor. In Java, we traditionally use the synchronized keyword to achieve this kind of locking. But ReentrantLock offers more flexibility and features. Can you explain what reentrant means in this context?
Certainly. Reentrant means that if a thread already holds the lock, it can acquire it again without blocking. It's like if you're in the bank vault and need to go back in after a brief exit. You don't need to wait in line again.
That's a helpful explanation. So how does ReentrantLock differ from using the synchronized keyword?
Great question. While synchronized is implicit and tied to a specific code block or method, ReentrantLock is more flexible. You explicitly acquire and release the lock, which allows for more complex locking scenarios. For example, you can attempt to acquire a lock and do something else if it's not available, which isn't possible with synchronized.
That flexibility sounds useful. Are there any other advantages to using ReentrantLock?
Yes, there are several. One significant feature is the ability to set fairness. A fair lock ensures that threads acquire the lock in the order they requested it. This can prevent thread starvation, where some threads might wait indefinitely.
Interesting. How would you implement fairness with ReentrantLock?
It's quite simple. When creating a ReentrantLock, you can pass a Boolean parameter to the constructor. For example, new ReentrantLock true creates a fair lock. However, it's worth noting that fair locks can have a performance overhead, so they should be used judiciously.
That's good to know. You mentioned earlier that ReentrantLock allows you to try acquiring a lock. Can you elaborate on that?
Certainly. ReentrantLock provides a method called tryLock. This method attempts to acquire the lock without waiting. If the lock is available, it gets it and returns true. If not, it immediately returns false. This is particularly useful in preventing deadlocks in certain scenarios.
That sounds like a powerful feature. Can you give an example of when this might be useful in a real-world scenario?
Absolutely. Imagine a scenario where you're developing a restaurant ordering system. Multiple waiters, threads, are trying to submit orders to the kitchen. If the kitchen is busy, instead of waiting indefinitely, a waiter could try to acquire the lock, and if unsuccessful, move on to other tasks and try again later. This keeps the system responsive and prevents waiters from being stuck waiting.
That's a great example, Victor. It really illustrates how ReentrantLock can improve system responsiveness. Are there any common pitfalls or best practices our listeners should be aware of when using ReentrantLock?
Yes, there are a few important points to remember. First, always release your locks in a finally block to ensure they're released even if an exception occurs. Second, be cautious about acquiring multiple locks to avoid deadlocks. And third, remember that while ReentrantLock offers more features, it also requires more careful management compared to synchronized blocks.
Those are valuable tips, Victor. As we wrap up, could you mention a few advanced topics related to ReentrantLock that our more curious listeners might want to explore further?
Certainly, Sheila. For those wanting to dive deeper, I'd recommend looking into condition variables, which allow for more complex thread coordination. Also, explore the concept of lock striping for improving concurrency in hash-based collections. Lastly, read-write locks, which allow multiple readers but exclusive writers, are a fascinating extension of the locking concept.
Thank you, Victor. This has been a comprehensive look at ReentrantLock. To recap, we've covered what ReentrantLock is, how it differs from synchronized, its reentrant nature, fairness, the tryLock method, and some real-world applications.
Exactly, Sheila. ReentrantLock is a powerful tool in Java's concurrency toolkit. While it requires more explicit management than synchronized, it offers greater flexibility and features that can significantly improve the performance and responsiveness of concurrent systems when used correctly.
That's all we have time for today. Thanks for tuning in to Crashcast Java. If you found this helpful, don't forget to subscribe for more deep dives into Java concepts. Until next time, happy coding!